Hi, we're the Flight Simulation Chair Project Team, or FSC for short. My name is Hannah Trin, and I'm the project lead.
My name is Minsu Choi, the safety officer.
My name is Alberto Garcia.
My name is Kevin Kwong.
My name is Abraham Hassan.
And our faculty advisor is Professor David Rinkensmeyer. For this presentation, we'll first go over the history and vision of our project. Then we will head into the team structure, including each member's responsibilities. Then we'll go into the project breakdown, as well as the systems implementation. Then it'll lead into the budget of our project, and we will close out with our future steps. So this project is a simulation project, which means that it replicates real-life experiences. Specifically, our simulation chair mimics the experience of piloting an aircraft. It was first started in 2017 under the name XFADE, but after the academic year, the project was left in a non-functional state. As a result, we picked it up this year with hopes to reanimate the project in its original form. However, we wanted to add an additional play style, allowing the user to maneuver the chair in a similar fashion without having to play the virtual reality video game. So as a result, we have two modes of play style for our project. The first being remote control with just the joystick to the chair, and then the second being virtual reality control, which moves the chair in conjunction with a VR game.
So to outline our goals and objectives, we have to design and create two scripts that will be simulating the desired chair movement in a smooth manner. We'll be also identifying all errors between actual and desired position signals. We'll implement any necessary controllers to reduce that error as much as possible. And as far as hardware, that will remain untouched. For our team structure, we have mode 1, which is remote control, which is myself and Alberta. Our responsibilities as a part of this team is to design scripts implementing coordinate data from a joystick of PCB wiring capabilities with positional data from sensors on the chair. For mode 2, which is VR control, we have Minsu, Hannah, and Kevin. Our responsibilities is to implement positional data from the chair sensors with real-time VR coordinate data and obtain those through a supplementary simulation application.
For the project breakdown, this will happen in two phases, first being the hardware and then the software. On the right of the screen, you have the hardware breakdown. The electronic components consist of an Arduino microcontroller, which we use as our processor, as well as the PC system and Oculus Rift, which are required for game usage. Secondly, we have ergonomics. The user has a very uniquely shaped ball chair, which helps the experience of sitting in a single occupancy aircraft. Lastly, we have our propulsion system, which is fully pneumatic. It consists of two pneumatic servo valves and two pneumatic pistons, which move in two rotational axes, the roll and pitch axes. And it is supplied with compressed air at 50 psi. On the software side of it, we have SimTools, which is a simulation application that retrieves positional data from a VR video game. In addition to that, we have the Arduino under software as well, because we utilize its integrated development environment and its personalized language to write our own scripts.
So in order to begin our testing with our project, we had to develop some scripts that involve some value mapping. Our 10-bit binary numbers, for example, 0 to 1023, to 8-bit binary numbers, 0 to 255, in order to utilize certain functions within the Arduino program. Also, it was essential to use a proportional integrated derivative controller to have better stabilization in the chair and a much more smooth movement for the user. So in order to obtain values from the joystick, we had those the terminals connected to pin 0 and 1 in order to get those 10-bit binary numbers, and then we also used analog write to send a signal to the servo valves in order to actuate our pistons. We also use nested if statements in order for the corresponding value to send an action towards our pneumatic cylinders. It was also important to have a dead zone in our script because the slightest touch of a joystick resulted in random movements in the chair. So that our dead zone acted as our stabilization zone.
So for PID control, we had to implement a PID controller, and this is necessary so that the chair can operate in a rather smooth manner. This will also reduce the errors that we're getting when the chair is moving in accordance to the joystick. This is done by applying the three major parameters of PID, which is proportional, integral, and derivative gains, which will be adjusted to reduce that error. While tuning the script, we found out that KP and KD within the script showed the most effective in stabilization, while KI, which is the integral value, is manually controlled by the the geometer wired on the chair. It accounts for the motion intensity or the different weights of an individual. The effects of adjusting the gains needs to eliminate the error. Therefore, an error analysis of the desired and actual positioning signals needs to be conducted through the definition of error, which is E at T is equal to the desired position minus the actual position in real time.
One of the first things that the team started to work on was making sure that the connection between the Arduino and the computer was established. When we found the project in its state from previous teams, the Arduino, whenever code was uploaded to it, even simple codes like math, they would just result in errors. It turns out that the Arduino was connected to a multi-USB port, which created a lot of interference in it, preventing codes from being uploaded properly. By connecting our Arduino directly to one of the computer's USB ports, we were able to solve this issue and codes would be able to be uploaded with no problem. Since the Arduino was working after that, the Mode 2 team was able to begin working on communication between the Arduino and SimTools. The communication between Arduino and SimTools is extremely important as it allows us to be able to take position coordinate data from the flight simulator into our Arduino and then output those to SimTools, which would update its axes based on the axes that are read from the flight simulator. However, we were not able to access the actual values that the flight simulator was outputting, and research is still continuing on how to output that data.
In addition to that, we also did population testing. We based off our knowledge from SimTool data to the original code. These are the two tests that was conducted to determine if the arrays that we declared are getting filled with character data from the SimTool. The arrays value R and value Y, as you can see in this picture here, they were initialized with the values of zeros. The arrays will be filled with characters data that utilize a function called map that would convert the values to a new range and then be printed. However, the values only corresponded to zeros that the arrays were initialized with, which are -80 to -100. In summary, we have not been able to collect the data from SimTools. And for the budget, we were given approximately $2,000. And for this quarter, we did not utilize our budget because the previous team has already built the chair. In the future, we will consider purchasing DC motor and host shield to improve the flight experience if our current setup in the circuitry is still not functioning.
As Mitsu has stated, due to setbacks of our pneumatic system, a discussion of transitioning to a fully motorized system will take place next quarter. If we do decide to take this road of action, then 2 motors will need to be purchased and implemented in place of the pneumatic valves and pistons. In addition, a motor drive controller will need to be implemented as well to gain control over these motors. And lastly, we will continue consulting the online open forum X Simulation, which is hosted by SimTools, the simulation program we are utilizing for this project, in order to gain additional resources and innovative solutions to our issues.
Thank you.
Thank you.
Thank you.